Welcome to the next session of Programming for Problem Solving. The topic for the day is searching. Now, what is the searching? Searching refers to the process of looking for a record or item in the list based on some key. So it is an operation basically to find some information related to an item. Item is something that we want to search for. Where we want to search for? We want to search for that information inside a list. And how we are going to search for that information inside that list? We are going to search for that information inside that list based upon some key. For example, let us suppose that we want to find the contact information of a student based upon the roll number. So what is the list? It is a list or a record of students of all classes within a college. Now, what is the key? The key is the roll number, because we know the roll number of the student. Now, what is the roll number of the student? Let us say 101. So 101 is the roll number of the student. So 101 becomes the item, student record becomes the list, and roll number itself becomes the key. Only the value of that key is known and not the actual location in the list. So what we are basically concerned about is we are concerned about finding the location where that record is placed in the list. In this video lecture, we are going to study two types of techniques. One is called the linear search and the other one is called the binary search. So what is a linear search? Linear search is the most basic and easy to implement search algorithm. Basically, it is so easy because it does not apply any logic for the optimization of the search algorithm. Starting from the very first element or record in the list, it continues to search for the given item in the linear fashion. For example, if you have 100 students standing and you are looking for a student and you know the student by face, then you start with the very first student in the line and then look for the student in a linear fashion one by one till you find that student in the line. So basically you are not applying any logic. You are just starting from the very first student and linearly approaching the search. The complexity is dependent upon the number of elements in the list. How much time will it take? It will directly have a bearing on the number of students you have. If the number of students are less, the complexity will be less. If the number of students are more, then the complexity will be more. So this is the basic program of a linear search. Here you can see that first of all, we need to create a list in which we are going to find the element inside the list. So as you can see in this program, an array of 100 elements has been created. So this array will act as a list in which we want to find the item. So here you can see we have created an array with a maximum of 100. So you can have a list of only 100 elements in this program. So now we are going to ask how many elements you will have in your list, and that will be represented by n. So 100 is the maximum number of elements you can have, and n is the number of elements we will eventually have. The value should be less than or equal to 100. And then we are going to accept the input for all the elements of the array less than n. So that means if the value of n is 80, then we will accept 80 elements starting from 0 up to the maximum value less than 80, which is 79. So that means 0 to 79. And the input will be saved in the array using this notion. Array square brackets C. The value of C will be initialized to 0 and then it will go up to 79. Now we want to search for the item. So that element that we want to search for will be stored in the variable named search. So basically what we want to do, we want to search for the element whose value is stored in the variable search in the array. So what we are now going to do is, now we are going to search for that element one by one in the list. So what we are going to do now, as you can see here, a for loop will be run. So the for loop, as already stated, that in the linear search we are going to start from 0 and we are going to go till the last element. So two things can happen. Either we find that element within the list or we do not find the element within the list. So if we find the element within the list, then this condition will be true. Array of C is equals to search. So that means we are able to successfully find the element in the list. So where did we find that element in the list? We found that element at position number C in the list. So C alone indicates the location where the element has been searched. So what to do if we have successfully found the element in the list? We can simply display a message that the element is present at the location %d, and %d is denoted by C plus 1. Basically because the index starts from 0, so the actual position is C plus 1. So we found the element at position C plus 1. If we do not find the element at position number C, then the next iteration will take place and the value of C will be incremented by 1. So we will now search for the element at the next position. So once this total loop is successfully executed, or the break statement is executed because we find the element of the array, we reach at this line. This is the key line. If C is equal to N. What does it mean? It means that we were not able to find the element in the list from 0 to 79. So when the loop terminated, because we were not able to find the element from 0 to 79, the value of C became 80, which is equal to N. So this particular statement indicates that the element could not be found. If it is true, then we can display the message that %d means the element itself. The element isn't present in the array. So as you can see, this is a very basic algorithm, very easy to implement, no strict logic, no pre-requirement at all. You can simply get a list, take the input, and then find an element inside the list. Now, because it is very easy, obviously comes with a disadvantage that the efficiency depends upon the value of N, and you cannot implement a linear search algorithm when you have a very, very large set of items. So this is an example of the linear search. As you can see in this, the total number of elements in the list are 9, starting from 10, 50, 30, 70, 80, 60, 20, 90, and 40. Because the total elements are 9, the smallest index in C programming is 0 and the maximum is n minus 1, that is 9 minus 1, 8. The problem is to find the location of element number 20 in the list. So from where we are going to start? We are going to start from the very first element in the list. The very first element in the list is 10, which is not equal to 20. Because 10 is not equal to 20, we will increment the value of the index and then we will search for the element at the second location. The value is 50, which is again not equal to 20. Hence, we will search at 30. Then we will search at location number 70, then 80, then location number 5, 60, and then location number 6 or the index 6. And the value of the item at index 6 is 20. and which is equal to the item that we are searching for, and hence we found the outcome. So where did we find the item? We found the item at index number 6. The position is 6 plus 1. Now because we were able to find the item in the list, that means 6 is not equal to 9, which is the number of elements. 6 is not equal to 9 because we were able to successfully find the element in the list. Let us suppose that we were searching for 21, then you can see that 21 is not in the list. And if you reach at index number 8 and then increment the value of 8 by 1, then it becomes 9, which is equal to n, that means number of elements, which means the element could not be found in the list. So this is a basic algorithm, and you can see how we have approached to find the location of the element with value 20. It was found at index number 6. The next is binary search algorithm. The binary search algorithm is very efficient algorithm, and it is much better than the linear search algorithm in terms of performance. But it has a few limitations as well. A binary search algorithm can be implemented only on sorted lists. So this is the biggest issue with the binary search algorithm. Binary search algorithm can only be implemented if you are given a sorted list. Now that sorted list can be in the ascending order or the descending order, it does not matter, but the list has to be sorted. Binary search follows the principle of divide and conquer. So what you have is a large list, and we are going to find the middle of the list as it has been specified here. We are going to compare the item that we are searching for with the element stored at the middle position of the list. Now three things can happen. Either the item is equal to the element that is stored at the middle of the list, which means that you have found the element, and that is the end of the algorithm. But if you have not found the element at the middle position of the list, then two things are possible. Either the element is smaller than the element at the middle, or the item is greater than the element at the middle position. Now, if the element is smaller, that means it could be present only in the first half of the list. And if the item is greater than the element in the middle, then it could only be present in the second half of the list. And that is why the binary search follows the principle of divide and conquer. In every step, it actually halves the list. So we will see further, and the things will be more clearer to you with the help of a program and an example. So this is the program of the binary search algorithm. So let's have a look at the program. So in this, we are going to create a list of 21 elements. As you can see, the list has been created with the help of an array, as you can see here. So the total number of elements in the array are 21. So what is going to be the position of the first element? The position of the first element is going to be 0. The position of the last element will be 20. And what will be the position of the middle element? The position of the middle element will be 10. So in this case, we have fixed it, but you can also take the size of n from the user and then compute the first, last, and middle. So in this case, the size of the list, that is 21. The first element is at position number 0, the last element is at position number 20 or index number 20, and the middle element is at index number 10. So first of all, we are going to accept the input for all the elements in the list. For that, we are going to use this for loop. This for loop will help us to take the input from the user. Now we want to accept from the input from the user about the element that we want to search, and that element will be stored in the variable search. Now let us start with our algorithm. Our algorithm will continue to find the element till the value of first is less than equal to last. So the value of the first is 0 and the value of last is 20. So we will start with our search. What we are going to do, please concentrate here. What we are going to do, we are going to check 3 conditions, of which we are going to write the condition for 2. If the first 2 conditions are false, that automatically means that the condition number 3 is correct. So what is the first condition? The first condition is if the element in the middle of the array is less than the element that you are searching for. The second condition is if the array element at the middle is equal to the element that you are searching for. If it is not less, it is not equal to, then automatically it means that it is greater than the element that we are searching for. Now let's take an example here. Let us suppose that we have a list something like this, and this is the middle, and the value of the element at the middle, let us suppose, is 50, and the element that we are searching for is 35. Now what we are going to do is we are going to compare this 35 with 50. Now 35 is less than 50. Now the element cannot be in this part of the list because the list is in ascending order and all the elements on the right hand side of 50 are greater than 50. So that means if the element 35 exists in the list, it can only exist in the left of 35. So now this becomes the list that we are going to search for. So what will be the new parameters? The first will remain the same because in the initial list this was the first, so it will still remain the same. But in the first list this was last, and this last will now become one less than the middle, as you can see that it has been stated here. Last is equals to middle minus 1. This will be executed if the value of the search or the variable that we are searching for is less than the element in the middle. Now what if it is greater than the element in the middle? So what if it is greater than the element in the middle? That means it will exist on the right hand side. If it exists on the right hand side, then there will be no change in the value of the last, but first will become middle plus 1. And what if the element has been found? If the element has been found, the element has been found at position middle. So we are basically going to return that the element has been found at this location. Now, let us suppose that the element has not been found and we have shortened our list, either the left hand side or either the right hand side. If we have found a new list, we need to compute its middle again. So the value of the middle is first plus. Now if the element was not found even once in the list, that means this statement was never executed, because this statement will only be executed if you are able to find the element at the middle position. Now if this statement did not execute, and that means that at the end of the loop you are going to reach at this statement, and you are going to reach at this statement only when the element was not found in the list, and hence you are going to return -1, which indicates that the element could not be found in the list. Now we will have a look at an example of what is binary search. Now as you can see in this list, this list consists of 10 elements. So when you have a list of 10 elements, if we go by our program, then the value of the variable start means the value of the location of the first element is 0 and the value of the last element is 9. So I repeat this thing. The value of the first element is, or not the value, but sorry, the index of the first element is 0. The index of the last element in the list is 9. And the index of the middle element is 9 divided by 2 is equals to 4. And what is the value that we want to search for? Let us suppose that we want to search for 23. Now, what is the value of the element in the list at index number 4? As you can see in the figure, the value of the element at m is equals to 4 in the list is 16. Now, is 16 equal to 23? The answer is no. Now, is 16 less than 23? The answer is yes. 16 is less than 23. That means the element might exist on the right hand side of 16 because the list is in the ascending order, and hence this list has been halved. So where we are going to find our element now? We are going to find our element in this list because 23 is greater than 16 and hence it cannot be on the left of 16. It can only be on the right of 16. And now we are going to search for the element on the right hand side. So now because we are going to search for the element on the right hand side, you can see there will be no change in the value of last. Last will stay the same, that is 9. But the value of the variable first will change and the first will now become 1 more than the middle, which is 5. Now if you have first is equals to 5, last hasn't changed, what will be the value of the middle element? The middle element will actually become 5 plus 9 divided by 2. That means 14 divided by 2 is equals to 7. So now compare the value of 23 with the element at index number 7. So 23 turns out to be smaller than 56. That means it can only be present on the left hand side of 56 in this list. So where should we now search for the element? We should search for the element on the left hand side of 56, which is this. So now our list has been reduced to these two elements. The value of start will not change. The value of the first element will still, the index of the first element will still stay 5, whereas the index of the last element will be 1 minus the middle, which is 6. So what will be the new value of the last? The new value of the last will be 6. And what will be the new value of the middle? The value of the new value of the middle will be 5 plus 6 divided by 2, which is equal to 5. Now look for the element at location number 5 or index number 5. It is 23, which is equal to the element that we are searching for. And hence the element has been successfully found. And it has been successfully found at location number or index number 5. So we are going to return 5. So this is how the binary search algorithm actually proceeds. The idea is to use the divide and conquer policy, compare the element with the middle element. If the element is found, return the value or location of the middle. Otherwise, look for the element on the left hand side of the list If the element is greater, then look for the element on the right hand side. Complexity of the linear and binary search algorithm. How many steps will it take to find an element inside the list using the linear and the binary search algorithm? A linear search scans one item at a time without jumping to any item. So that means the worst case complexity is ON, which means that it will take n number of steps to find an element in worst case. What is the worst case? If you are looking for a student in a line, the worst case is that the student is standing at the last position in the line. So how much time will it, how many steps it will take? It will take n steps. And if the value of n is very large, then the complexity will be very poor. The binary search however, cuts down your search to half as soon as you find the middle of the sorted list. So that means with every step you half the list, because when you look for an element at the middle position, if the element is not found at the middle position, then there are only two possibilities. Either the element is available in the list left to the middle or right to the middle. So that means with every step you half the search area. That is why the worst complexity of the binary search algorithm is log of n. This is much lesser than the linear search algorithm. So you should always prefer the binary search algorithm when you have a sorted list with you. Otherwise, you can go for the linear search. There are many other search algorithms that are available, but those are beyond the scope of this lecture and the subject. So I hope you enjoyed the lecture and you were able to understand the basic concept of searching, what is the importance of searching, how we perform the searching, and the two types of algorithms. Also, you were able to understand the comparison between the two algorithms, what when you should prefer the linear search and when you should prefer the binary search. Thank you very much.